Hello and welcome to another video for Year 9 Maths D. So today we're going to do the topic direct variation. So this one's going to be simple. It's just that you have to remember this relationship for any simple direct variation equation, which is y equal kx. Now, don't forget that later you will have to somehow change either y or either x. So it's going to depend on your example or the question. So let's just straight away answer example number one. So now example number one, find the equation connecting x and y. So what we're going to do is in first one, so let's have a look here. Y is proportional to x, so basically this one is y equal kx, and don't forget that k is your constant of proportionality, so whatever the value of x and y, k will remain the same. So that will answer the last question. The value of k for every values of x and y, the k is going to be the same. Right, so let's start here. We use the first pair of x and y that we see, which is 5 and 3. So we're going to substitute into the equation above, y equal kx, to find k. So x equal 5 and y equal 3. Okay, so let's substitute into this one. So y is 3 and k times x is k times 5. So it becomes 5k. Now, when you move 5 to the other side, it will become division. So you will straight away get k equal 3 out of 5. Therefore, the equation that you have that connects y and x will be y equal 3 out of 5x. So this is your answer for the first one. Right, what you notice about the value of k, I have mentioned just now, whatever the value of x and y, you will have the same k. So let's check whether it's true or not. Okay, for the first one, you have proven this. So I just put a check over here. Let's have a look at the second one. So k, from your equation here, you can say that k equal y out of x, right? So let's have a look here. K equal, for the second one, which is this one, right? So x equal 10 and y equal 6. So k equal y is 6 out of 10. So that's for the second value. 6 out of 10 can be simplified into 3 out of 5. Let's have a look here. Is it true that k equal 3 out of 5? Yes. So you can see here also yes. Okay. And let's have a look for the last one. The last value will be 15 out of 9. Now, okay, so let's have a look here. K is also equal y out of x, right? So y out of x is 9 out of 15, which can be simplified into 3 out of 5. There you have it. Okay. So for any direct variation, you have to make sure that the k is always the same, right? So that's the first example. All right. Now let's have a look at what if you have two variables that are related in more complicated ways. So let's have a look here. You can see the question, example 2, y is directly proportional to x squared. And you can see that here you are given two values initially when x equals 5, y equals 10. So let's straight away go into part A, find the equation connecting x and y. So you can see here that y is directly proportional to x squared, and you can change it straight away into y equal kx squared. Right, so look at A, can just put it here, y equal kx squared. So we use x equal 5 and y equal 10, and you substitute into the equation over here, and don't forget that x is squared. So y equal 10 equal k times 5 squared. Right, so 10 equal 5 squared means 25, so you have 25k. And you can see here when you move 25 to the other side, it becomes division. So k is equal to 10 out of 25, And when you simplify 10 out of 25, you will have 10 divided by 5 is 2 and 25 divided by 5 is 5. So there you have it. You can straight away tell that y equal k is 2 out of 5 x squared. Right, so this is your answer for the first question, because you have to find the equation connecting x and y. Now, let's have a look at part B. You find the value of y when x equal 15. Now, here is the situation where you are given one value and you have to find the missing value. So here you're given x equal 15 and you have to find y. So you are going to use this. You are going to use this one, right? Okay, so later, okay, let's write down back y equal 2 out of 5 x squared, and you know that x is the value that is given, so just put in 2 out of 5 x squared, so equal to 2 out of 5 times 15 square. So you can check by your calculator. 15 square is 225, and when you simplify using calculator, y equal 2 out of 5 times 225 equals 90. So that's it for the part B, right? So this one just a simple one, but sometimes the value of the variables that are connected may be different. Sometimes x squared, sometimes maybe other than x squared. All right. So let's have a look at the last example, which is taken from the past year paper, June 2007, in paper 2, question number 7. Alright, so let's have a look here. The volume of water in a container is directly proportional to the cube of its depth. When the depth is 12 centimeter, the volume is 576 cubic centimeter. Calculate part 1, the volume when the depth is 6 meter, and part 2, calculate the depth when the volume is 1300 cubic centimeter. Now, for the first part, you have to identify what are the two variables that are connected in your question. So here, you can see here that the volume of water is directly proportional to the cube of its depth. So let's choose what you're going to use for your volume and depth. So the alphabet, I mean the variable. So let's say I consider V for the volume, right? And directly proportional, of course, the symbol, and cube of its depth. Let's say depth is small d, so cube of depth is d cube, right? So you have V equal, don't forget your constant of proportionality, k times d cubed. Now, when the depth is 12, you are given d equal 12 centimeter. So the volume will be 576. You're going to use that to find k first. So here V equal 576 equal k times d cubed. And here I will just use a shortcut to find k. So k equal 576 divided by 1728. So when you check your calculator, don't forget that this paper too, you can check your calculator to use to find this. So this simplified will become 1/3. So you have your equation already, which is equal to V equal to 1/3 d cubed. So this is your equation connecting V and D. Now let's have a look back at the question. You are to find the volume when the depth is 6. So the value that is given is only D. So you're going to use your equation over here, D, and then you have to find V. So V equal 1/3, substitute D, which is equal to 6 cubed. So calculating by yourself, you can get 72. And don't forget that you're talking about volume, so it is cubic centimeter. according to your example above. Right? Now, you have your equation already, so let's answer part 2, where you're going to find the depth when the volume is 1300 cubic centimeter. Now, let's rewrite what you have previously, which is this one. Right? And let's circle what you're given. You are given the volume, so right? So V, you just substitute into the equation, this one, right? And when you change d cubed into the subject, obviously you can see here that 1/3 will be moved to the other side. You multiply by 3, so d equal, d cubed, don't forget the cube, equal 3 times 1300, which will become 3900. Now when you see, when you have a look at d cubed equals 3900 over here, obviously you have to make the cube move to the other side, so the opposite of cube is cube root. So d, here d will become cube root 3900, and you can have an answer that is quite a lot of digits involved. So let's take 15.741, and let's take the 3 significant figure. So your answer in the end will become approximately equal to 15.7 centimeter, right? So that's it for the explanation for this topic. Don't forget that this will be sticked in your page 40 and 41. Okay, I hope that it will help you. Okay, thank you very much and see you again.